We're getting really close to the end now, but today we're talking about 4. There are 4 basic arithmetic operations. Everybody watching this video probably knows the 4 arithmetic operations. There's addition, subtraction, multiplication, and division. And interestingly enough, 2 of the 4 arithmetic operators are also names of Ed Sheeran's albums. And I'd totally not be surprised if that ever becomes 3. But then there's a bigger question. What do these 4 arithmetic operators actually mean? So, for this video we're going to try to explain that, and we're going to be doing it by using something called a number line. A number line is just simply a line looking a bit like this. All the real numbers are all going to be found on the number line somewhere. Now if I want to represent a value like 2 on this number line, I can draw an arrow starting from where the number line starts, or at 0, all the way out to the number 2. And that line will have a length of 2. Okay, so let's start with addition. What does it mean to add a number on our number line? So let's say we're trying to add 2 and 3 together. What's 2 plus 3? First I can draw this arrow which will have a value of 2. Then I can have another arrow with a value of 3. And adding 2 and 3 together is just to put these 2 arrows end on end and see what the length of that new formed combined arrow would be. So if I add 2 and 3, I can put the arrow for the 2 and then the arrow for the 3 together, and then I can see that the number goes from 0 to 5. So 2 plus 3 will be 5. Or similarly, I can do something else like 1 plus 5. Put the 1 arrow and then put the 5 arrow, and then we get 1 plus 5 equals 6. Now what if I do something like 4 plus 0? What does this mean? Well, I can put the 4 out, and then I can put another arrow which has got a length of 0. So what's the new length of this arrow? As you can see, the new length of the arrow doesn't actually change. What it's saying is that 4 plus 0 will still remain as 4. And in fact, this is true for any case. You can add any number by 0 and you'll still get the original number. This 0 here is what we call the additive identity, which means that we can add 0 to any number and we'd still get that exact same number. So now let's say I have an arrow of length 3. And I want to add another number to that 3 so that I get the additive identity, or 0. What number do I have to add to 3 to get back to 0? On the number line, if I draw it out, this arrow have a length of 3. And to get this arrow to cancel itself to go back to 0, I have to make this arrow go back by 3 units in the opposite direction. And so the number that I'd add would be -3, which is just basically going 3 units, but in the opposite direction. And 3 plus -3 will in fact do give you 0. This -3 here is what we call the inverse of 3. The inverse for addition is just basically the number, but you change its symbol from positive to negative or negative to positive. And any number when added to its inverse will give you 0. When you add a number, you just, well, add the actual number. But when you're subtracting, you're also adding, but rather than adding it by the actual number, you're adding it by the inverse of the number. For example, if you have 5 minus 2, subtracting is like adding the inverse. So basically, this is like saying 5 plus the inverse of 2, or 5 plus minus 2. And if you add 5, and then you add minus 2 to it, you get 3, which is basically what you get when you subtract 5 from 2. So that was addition and subtraction done. Now we'll move on to multiplication and division, where, as you'll see, a few similar questions can also be raised. One big difference between addition and multiplication, though, is that multiplication will involve scaling of the arrow to change the arrow so that it's a different size. Let's see what I mean by this. So let's say I want to find out what 3 times 2 is. Well, again, I'll start with an arrow of length 3. If I multiply by 2, what I'm basically doing is I'm stretching this arrow by a factor of 2. Well, what this means is that the new arrow, after it's being stretched, will have a length which is the same as 2 of the old arrows. So the new arrow would have a new length of 6. And that is exactly what we find when we multiply 3 by 2. 3 times 2 is 6. You could also think of multiplication as repetitive addition, but for the purpose of this video, I won't mention that too much. Now again, if I have something like 4 and I multiply it by 1, what does this mean? Well, I'll have an arrow of length 4, and then I'll scale it, I'll stretch it by a factor of 1. If I stretch an arrow of length 4 by a scale factor of 1, I'll still get an arrow of length 4. I'll basically not be stretching or shrinking the arrow at all. And this applies for any number you're multiplying by 1. If I take any arrow and I try to shrink or stretch it by a factor of 1, I'll still get the exact same arrow. And so 1 is what we call the multiplicative identity. When you multiply any number by 1, you'll just get back to the same number. Okay, so then we can raise that exact same question again. If I have an arrow of length, say 3, what number do I have to multiply by to get it back down to the multiplicative identity, or 1? What is the factor that I have to stretch the arrow of length 3 by in order to get it back down to the arrow of length 1? Well, the answer is you'd have to stretch it by a factor of 1/3, which means that the arrow will end up being 1/3 of the original length. And so if I have the arrow of 3 and I stretch it by 1/3, I'll get an arrow of length 1, which is the multiplicative identity. And that is in fact true with multiplication. 3 times a third will actually give you 1. And this 1/3 is what we call the inverse of multiplication. The multiplicative inverse of a number is just basically its reciprocals, and to find the reciprocal of any number, you just have to flip it around. So for example, we have number 4. The multiplicative inverse of 4, or 4/1, is just going to be 1/4. The multiplicative inverse of 3/2 will just be 2/3, and etc. If I take a number and I multiply it by the inverse of multiplication, I get the multiplicative identity, or 1. And so finally we can move into division zone. Division is the inverse of multiplication, or in other words, dividing is just basically multiplying by the inverse. So for example, 6 divided by 2. I have an arrow of length 6 and I want to divide it by 2. Well, dividing by 2 is like multiplying by the inverse of 2, or multiplying by a half. And so 6 divided by 2 will be the same as 6 times a half. And if you do the shrinking and stretching, you'll get 3. And 6 divided by 2, in fact, does equal to 3. But yes, guys, this is the really basic, quick explanation for the 4 basic arithmetic operators.